These are the frequently asked questions for Algebra 2 for the homework for section 4-5, day 2. And the first one that people might encounter a little trouble with, so it's going to give you a little sketch of what's going on here, is number 27. And what you need to do is move your 19x and your 15 over to the other side. And then you'd want to go ahead and graph it. And when you do that, on your graphing calculator, you get something that looks kind of like this. But it's hard to see because on your calculator with the window set at what it is, it's hard to see that there's an actual crossing going on there. So what we have to do is we have to focus on the X's in your window that would give you a better view of what's going on. So I notice with my graphing calculator, it looks pretty much like it'll be somewhere between -1 and -3. So I hit my window on my graphing calculator and I'm going to change my x minimum to -3 and my x max to -1. And when I do that, I can definitely see a little bit of the dip underneath there. So it changes a little bit. But again, now I've got all these y's that I don't necessarily need. So my y's, I will change those to going from, well, let's just go -1 to 1 with the y's, just to get a closer look at it. And when you do that, you can definitely see the two dips below that you have there. So what you want to do is get Blinky over here to the left after you hit second trace 0, number 2, and hit enter at this spot. Then move Blinky over to the right and hit it again, and then hit your enter through guess, because we don't want to take a guess. And that will get you the far left one. And the far left one was a -1.670. And then you want to set Blinky up again, but this time below it is to the left. So you're going to move Blinky right over there so you can see where that spot is, and then hit enter, and then go to the right and hit enter again, and hit enter through guess. And Blinky tells you that one is at about a -1.50. So having the window so that you can see those intersections is really important to using your calculator to do those. Then, the next one I thought would probably be 36. And 36 is going to be another one where you may have to mess around with the window a little bit if you're going to do this with the graphing calculator. So 36, part A, it says, when is the object going to be 1,000 feet above the ground? Well, feet is height. So that means we have to put that feet in for 1,000. But if we're going to find the zeros on the calculator, we're going to have to subtract that 1,000 from both sides and have -16t squared plus 700. Now this one you could do a little factoring on, not a whole lot. You could pull a -4 out of this and get 4t squared minus 175. And then we actually could solve this one with algebra because we want to know when is 4t squared minus 175 equal to 0. So you'd add 175 to both sides, then you would divide both sides by 4, and then we would take the square root. And because this is a word problem, you know, we would go ahead and just do the positive square root of this. And that comes out to 6.6 seconds. It's the same thing you would find if you plugged in this step, you know, into your calculator and then let the calculator do it. Then step B says, what about 940? So 940 equals -16t squared plus 1,700. Again, you'd have to move that 940 over. So 0 equals -16t squared plus 760. And this time you can take a -8 out of both of those, and that will give you 2t squared minus 95. And again, you don't need the calculator for this one because we want to know when is that 0. So 2t squared minus 95 equals 0. Add 95 to both sides. Divide both sides by 2. And then take the square root and only use the positive square root as your answer. And that comes out to 6.89 seconds. And then part C says, okay, what would be a decent domain and range for this? I'm gonna slip that over here. And so I start thinking about time, and pretty obviously, time in the air is not gonna last forever. And our biggest one here was 6.89, so I would probably say the time is gonna have to be somewhere between like 0 and maybe 12 or maybe even 20. But in this case, I think we're definitely good with saying it's somewhere around 10 seconds. And then our height, because we know that height started at 1700, that's going to be the highest cutoff, and pretty obviously when it hits the ground, it's going to be at 0. So that would be really good for our domain and range. Then number 37, for this one, you want to think, all right, I've got this picture that's 16 by 24, and we're going to add x on all the sides. So what we have to do is figure out what the whole area is and then subtract the area of the picture. And the entire area, well, this was 16, but now they've added 2x, so this is 16 plus 2x. And this was 24, but they've added 2x, so that'll be 24 plus 2x. So the area of the whole thing with the frame is 24 plus 2x times 16 plus 2x. But we're not going to put a frame over the picture, so we have to subtract the area of the picture, which is 16 times 24, or 384. And all of that needs to come out to their 276 square units. Well, then you go ahead and do your FOIL on these two in front here. And we have 384 plus 80x squared, or I'm sorry, plus 80x, plus 4x squared, minus 384 equals 276. So kind of interesting that the 384s drop out. And we have 4x squared plus 80x, and then we move that 276 over and set that equal to 0. And then, you could just go ahead and punch that into the calculator at this point and find the zeros. But a 4 does factor out of all of this. And again, because that 4 out in front doesn't have an x by it, it doesn't affect our 0 at all. So we could just punch this into the calculator, and it comes out at 3. So it will be 3 inches that we're getting our 0, our solution for that one. Then, number 38, we have a problem with a pendulum, and they tell us that it is 90 feet long. So we're going to put that in for L. And we are supposed to figure out t, the time, and the time is right there. It's t squared. We just have to solve for it. So we're going to divide both sides by 0.81, and then we're going to take the square root. And again, it's a word problem, so we're not going to worry about the negatives here. And that comes out to about 10.54 seconds when you do that. So you don't have to use your calculator for that one. You sure could. You could, subtract 90 from both sides and get a 0. So if you're going to put it into the calculator, it would look like this. And you could find the zeros that way. That's totally up to you, since they did not say we had to do it one way or another. All right, then number 40 says you've got a classmate that solved the quadratic equation that's shown over there in the yellow. Find and correct the error, and what are the correct solutions. I've warned you before never to look at their math as you're trying to do your steps, and it actually is right away here that they make the mistake. If you're going to solve something, you have to be finding the zeros, and finding the zeros means that it has to equal 0. So it was right in that first step that they messed up. They left the 2 over there on the right-hand side, and you cannot do that. You have to move that over. And once you get it into the correct form, this is really easy to factor. So we get a -4 and a -1 for x. So their mistake was they forgot to get a 0 on one side. Have to. If we're solving, we're finding the zeros. That means we have to get a 0 on one side. All right, then number 46 says we are to solve this by factoring. The first issue is getting that 9 over, so 3x squared plus 7x minus 9 equals 0. We don't have a common monomial factor, so we're going to need to look for that combination. So this is a combo problem that will make this work. And I'm just writing down all the factors that I have here. And then start thinking, okay, outside times outside plus inside times inside has to give me 7 here. And look for that combination that'll make that happen. So you sit there and you look for a long time. You've got 9 and negative 3. Well, that's going to give you 6. All right? How about negative 9 and positive 3? No, that's going to give me, you know, a negative 6 as well. I don't want that. That's not using what I need. So then you keep going. You've got 3 and negative 9, and we're not getting anywhere. And it doesn't take us too long, and we realize this one is not factorable. Doesn't mean we can't find them. You know, we just would really like to solve them by factoring if we can, but we can't. So you have to grab a calculator for this one and figure out what it is. And since some people get really weirded out when they, you know, can't figure out how it's factorable, 46 is not factorable. So just grab your calculator and find that one. And then 48, we have x plus 3 squared equals 9. Now, there are a lot of ways to do this one. I'm guessing that most of you would probably write out those x plus 3's, at least I hope you do. And you get x squared plus 6x plus 9 equals 9. And then you'd subtract 9 from both sides, and you'd be a little scared because some stuff drops out. But that's okay, because it's still factorable, and we can still get the zeros. It would be 0, and it would be negative 6. Those would be our two 0 values here. So x equals 0, and x equals negative 6. And that's not the only way to do that problem, so I wanted to show you another way. Because this is something squared, we can take the square root, and we'll get x plus 3 equals plus or minus 3, because whenever you take the square root, you get the positive and the negative square root, and then we would subtract 3 from both sides. So x would equal negative 3 plus or minus 3. So there's two solutions here. It could be negative 3 plus 3, which is 0, or it could be negative 3 minus 3, which is negative 6. So those are just two of the ways that you can solve that problem correctly, and that should do it.